you must have taken some snacks and all. So Dr. Rajan will again take up the floor. So you know that he has already spoken about the road infrastructures in India for the first session in this webinar. So now he will provide a glimpse on the structural pavement thickness design practices in India. So without further delay, I will hand over the floor to Dr. Rajan. Over to you, Dr. Rajan.
Thanks, Parveen, and thanks to all for being with us. And in this part, we will take you through this. What are the Indian practices for the flexible pavement design? So if you yes, so what kind of guideline we have? So we have this is the kind of typical guideline by IRC and Indian Road Congress, and it's like IRC 37 2018, and it revises with time and time based on the field experience, suggestions from the experts. With time it revises. So right now we have latest IRC 37 2018, and definitely based on the present experience, in future it will revise. So in
Bharat, sorry to interrupt you. Some participants are saying that the presentation is stuck somewhere. So
okay.
Can you get confirmation? Yeah.
Yes. So Parveen, can you see this is slide number 63?
Yeah, I can see it actually. I can see it. Possibly there might be some issue from their end, some internet issue or something like this.
Okay.
Because I can see it very clearly.
Go ahead. Yeah, no problem.
Yes.
Yeah.
Thank you, Parveen. So throughout this guideline, we may use some terms like CTB, which stands for the cement treated base. Then we can use the CTSB, like cement treated subbase. So you have to just be with us, and if these terms come, you can understand.
Dr. Rajan, just 1 second. Some sound is coming actually from the background. So I would request everyone to mute, and just only a speaker will be having a speaker on. Yeah, thank you.
Okay. Yeah, thank you, Parveen. So let's go to the next slide, and here we can see what are the key highlights of this flexible pavement design principle. So generally we design this our bituminous road for design life of 20 years, and if our road traffic demand is more than 300 million standard axle, then we go for the long life pavement or perpetual pavement. And design principle, we follow the mechanistic empirical design approach. We will little bit talk later on this particular design principle. And we consider the traffic more than 3 ton in the gross weight. If a vehicle is more than 3 ton in a gross weight, we consider as a part of traffic in design. And what are the input parameters? We have elastic modulus, cohesion ratios, and thickness of different layers. And axle load, standard axle, as I discussed in my first part, on the road you may see different kind of axle compositions. So we have to convert them in a standard axle. So in India we are kind of considering 80 kilonewton as a standard axle. Then we have this vehicle damage factor. To convert different kind of axle in the standard axle, we use the fourth power law, or is it terms as a VGF. So what are the critical parameters we are looking? We are looking for the rating, which is the kind of vertical compressive strength at the top of subgrade for the rating performance, and for the bottom of cracking, horizontal tensile stress at the bottom of the bituminous layer. And if we provide CTB as a part of structure layer, then we have to check for the tensile strength and stress at the bottom of CTB also. So let's see what kind of typical cross sections we have for the pavement design aspect point of view. So here you can see the first cross section. We have bituminous layer, we have a granular layer, and then we have a subgrade. So if we have this kind of combination, then we have to check for the rating. We have for the fatigue and all, we have to check this horizontal tensile strength at bottom of the bituminous layer, and for the rating we have to check the vertical deformation or strength at the top of subgrade. In scenario 2, it may possible you come up with the stabilized kind of layers as a part of base and subbase. As soon this stabilized layer come in the picture, we have to keep in mind we have to measure the tensile strength and stress at bottom of CTB. In addition to the tensile strength at the bottom of bituminous layer, we have to also evaluate this tensile strength or stress at bottom of CTB. We have to check this how much fatigue resistance our CTB layer it is there. And then one important thing we have to take care, as we provide the CTB, so there may chances of reflective cracking in the top layer. So we have to provide some crack relief layer. So here we are providing granular crack relief layer. So if we are providing granular crack relief layer, then we have to consider it as a part of a kind of structure layer that we have to consider. And if we consider the CTB and all, this is the kind of typical UCS range we have, and the elastic constant we have, that we have to consider while designing. In scenario 3, you can see we have bituminous, CTB, CTSB, everything we have. But we don't have here granular crack relief layer. But we have another crack relief layer, which we called as a SAMI, stress absorbing membrane interlayer. So what is this SAMI? It is the kind of some elastomeric polymer, and with the aggregates we apply in the thin thickness. And when we apply this SAMI, we should not consider it as a part of structure layer. So we have only structure layer, this bituminous layer, then CTB, then CTSB. That kind of structure layers we have. Again, CTB is there, so we have to evaluate the tensile strength and stress at the bottom of CTB. In the 4 different kind of cross section, we don't have CTB. We have CTSB, cement treated stabilized base, but we don't have cement treated base. On the place of CTB, we have emulsion or foam bitumen stabilized things. So as I said, in CTB we have to consider tensile stress and strain at the bottom of CTB, but here we no need to consider. We have to only consider these 2 criteria, rating and bottom up cracking. And for emulsion and this foam bitumen stabilized rep layer, we generally consider elastic modulus around 800 megapascal. As a part of 5th cross section, here you can see we don't have this any rep stabilized. We have normal granular base WMM. So again, we don't have CTB, so we have only 2 criteria for the performance evaluation. And if you see the 6th one, we have CTB, but we don't have CTSB. These are the all tentative kind of combinations of typical layers in the pavement design. Anyone we can adopt based on our kind of demand and based on our kind of expertise and field engineers and all. So again, as we provide the CTB, we have to consider the fatigue cracking in the cement treated base. So all these combinations we have. Now we see with all these combinations, and we discuss this mechanistic empirical design approach. So what we stand for the mechanistic, what we stand for the empirical. So in mechanistic, we have to measure stress, strain, and deflections. And what we use the linear elastic layer theory. And for that, in India, we have a software which is called as a IIT Pave. And what input parameters it uses? It uses the elastic modulus of different layers. Then Poisson ratios we have to put. We have to put tentative thickness, and then tire contact pressure input parameters we have. So for example, in case of the, let's say, bituminous mixage. So let's say my colleague Vamsi discussed BC and DBM. So based on the temperature and then type of binder, whether you are using viscosity grade binder or modified binder. So you have to come on the particular selection of the elastic modulus, which we also measure through this resilient modulus test. And when we use this wrap treated stabilize, as I said, the elastic constant value of 800 MPa we consider. It may be higher, it may be 2000, 2500, but we consider 800 MPa as a limiting. Then what we see what is the empirical. So in empirical we have some equations which derived based on the Indian experience and extensive field studies, and these equations have a reliability of 80% and 90%. So what are the input parameters for these equations? We need to input the design traffic, that definitely we will collect. If you want to design some road, we have to do the traffic survey and all, and we have to collect the design traffic. And the other parameter we have to put is the bituminous mix volumetric characteristics. So with this, we also consider what kind of bituminous mix and volumetric parameter we are putting as a part of top layer. And this is the kind of design traffic. You may feel some values are here, but due to some technical problem it are not coming. So we consider the design traffic. We have a rating model, we have fatigue model, and we from here we calculate the vertical compressive strength, horizontal tensile strength for given or for our what traffic we want to design for a particular road, and we also calculate this tensile stress bottom of CTB. And at last, whatever we calculated from empirical should be high than computed, whatever input parameters we are putting in mechanistic. So computed is the mechanistic. If it is so, our design is safe. If it is not, we have to change either layer thickness or we have to switch our selection of material. And if we see this pavement design summary, so initially we have to go with the calculation of design traffic, then different materials, whatever we select, we have to characterize their engineering properties, and that properties will helpful with the initial input parameters, this traffic and modulus values and all. Then we have to calculate based on the empirical approach, whatever formulas we have, and then after that we also calculate through the IIT Pave software. And again, as I said, if my empirical formula calculated allowable limits should be higher than calculated, my design is safe. If I don't have such kind of if it is IIT Pave software coming results are high, I have to go back and look back into my input parameters, change the material layer thickness. So that kind of practice we have. So ultimately it starts from the field, what kind of road you are putting, national highway, expressways, what traffic demand we have, what environmental climatic conditions we have. Based on this, we have to select the material. We have to perform the testing and collect these modulus values and all. What are the subgrade of kind of existing soil strata, that all consider as an input parameter. Then we do this empirical and IIT Pave software, and then we have to decide based on our how the values are playing in that. That's all. With this, I will conclude this pavement design part, and whatever questions you have, we again request put it in the chat box. We will take at the end of this session. Thanks, Parveen. It's over to you.
Yeah. Thank you, Dr. Rajan. It was very nice presentation. So you have actually covered